Hi, this is Chem 121. We're in Chapter 3. I'm going to do sections 3.1 and 3.2 in this lecture. So here's the PowerPoint for Chapter 3. We're going to do section 3.1, internal structure of an atom, and 3.2, atomic number and mass number in this lecture. So when we talk about internal structure of an atom, what we're talking about is the subatomic particles, the very small particles that are the building blocks for atoms. We're going to talk about three different subatomic particles in this section: electrons, protons, and neutrons, shown in this diagram. Electrons are the particles that are outside of the nucleus and have a very small or negligible mass. They have a charge of -1. So electrons are outside the nucleus and have a negative charge and a very, very small mass. Protons and neutrons, on the other hand, are found inside a structure called the nucleus in the center of the atom. Protons have a positive charge. Neutrons have no charge. And protons and neutrons both have a very large mass compared to electrons, and their masses are approximately equal to each other. So protons and neutrons are in the nucleus, electrons are outside, protons have a positive charge, and electrons have a negative charge. So here's a little learning check for you on subatomic particles. Choose the subatomic particle that fits into each one of these categories. Go ahead and pause your recording and answer these questions. So electrons are found outside the nucleus. Protons are the subatomic particle that has a positive charge. And neutrons have a mass, but no charge. So the nucleus is very, very small compared to the overall size of the atom. It's also extremely dense because it contains almost all of the atom's mass. And remember, it's positively charged because the protons are located in the nucleus. So here's just a little diagram that shows the relative size of the nucleus compared to the overall size of the atom that's occupied by the electrons that are outside the nucleus. So here's the nucleus, picture of the nucleus sort of blown up here. So that was section 3.1. In section 3.2, we're going to talk a little bit more about two things called the atomic number and the mass number. The atomic number is simply the number of protons in each atom of an element. All atoms of a particular element have the same number of protons in the nucleus. And this is what gives an element its identity. And this number can be read right off the periodic table. So if you don't have a periodic table printed out, you can just go to the handouts module in Canvas and download your periodic table so that you can look at it while we're talking about this part of the lecture. So the atomic number is just a single digit above the name of the element, and it can be read right off of the periodic table. So since atoms are neutral overall, they have no net charge, the number of protons in an atom is always equal to the number of electrons in an atom. So whatever number of protons an atom has, it's going to have exactly the same number of electrons because the positive atoms are uncharged, and the number of protons, which are positive, is going to be equal to the number of electrons in that atom. So let's just do a little exercise here to look at this a little bit. So looking at your periodic table, which you've either printed or downloaded, just look at the number that's right above the symbol for these elements. And that's going to be your atomic number, which you can write down in this box. You can, if you've printed out the PowerPoint, you can write it down. If not, you can just write it down on a piece of paper. And then based on that atomic number and what you know about the atomic number from this page, fill in the number of protons in that atom of that element and the number of electrons in an atom of that element. And remember, always pause your recording and make sure you do these learning checks and don't just go on to look at the answers. So when we look at our periodic table, there's a 7 above the N, which is the symbol for nitrogen. So that's its atomic number. There's a 30 above the zinc, and there's a 16 above the sulfur. And that atomic number tells us the number of protons in nitrogen, zinc, and in sulfur. And if those atoms contain that number of protons, they're also going to contain that number of electrons, because neutral atoms always have the same number of protons and electrons. The mass number, on the other hand, is the number of protons plus the number of electrons. So if we go back to our diagram here, where we had protons plus neutrons, the atomic number was just the protons. The mass number is the protons plus the neutrons, which kind of makes sense because we talked about the fact that the most of the mass of the atom is in the nucleus. And since the protons and the neutrons are what make up the mass, if you add the protons and neutrons together, it would make sense that that would be the mass number, because most of the mass of the atom is the protons plus the neutrons. So the mass number is the total number of protons plus neutrons. It gives the mass of the atom, and it's always a whole number. Now, this number actually doesn't appear in the periodic table, and in a few slides in the next section, we'll see why this number actually doesn't show up in the periodic table, but it is the number of protons plus neutrons. So if you had a single atom of lead, and its mass number was 207, use your periodic table to determine, first of all, how many protons are in the nucleus for lead. So based on what you already know, how do you figure out how many protons are in the nucleus for lead? And then based on the fact that you know the mass number, how many neutrons would be in that nucleus? And then how many electrons? Make sure you go ahead and pause your recording. So first of all, how many protons are in this nucleus? Well, the protons in the nucleus are going to be the atomic number, and that's the number that's right above the symbol for lead in the periodic table. So that number is going to be 82. That's the number of protons. Now, to figure out how many neutrons, you take the mass number and subtract the number of protons, because the protons plus the neutrons are what give you the mass number. So 207 minus the number of protons is going to give you the number of neutrons, 125. For the third question, how many electrons? Well, this is a neutral atom of lead. It has no charge. So in that case, the number of protons and the number of electrons are going to be the same. So an atom of lead that has 82 protons is also going to have 82 electrons. So in an earlier section in this class, we defined an element as a pure substance in which all the atoms present have the same, an element was a substance that only had one type of atom in it. And now we sort of have a new definition for an element, and that's a pure substance in which all the atoms have the same atomic number. The first definition was sort of a macroscopic definition, and this is a subatomic definition. So you can either define an element as a pure substance with only one type of atom, or we can define it as a pure substance in which all the atoms have the same atomic number. All atoms with the same atomic number have the same chemical properties and are atoms of the same element. The element sodium consists of atoms that all contain 11 protons in the nucleus. And remember, we use the word element to distinguish between pure substances that are elements and pure substances that are compounds. I think that was in chapter 1 when we talked about elements versus compounds. So that's sections 3.1 and 3.2.